Today we're going to continue talking about gas laws by talking about three different laws: Boyle's law, Charles' law, and Gay-Lussac's. So label today's notes with this label as well as today's date. So the first law is Boyle's law. It states that the volume of a given mass of a gas varies inversely with the pressure when the temperature is kept constant. So write this down, but also write down this over here. So P1 times V1 equals P2 times V2. So if our temperature is kept constant, if we increase the pressure, the volume will decrease, or vice versa. They're inversely related. So that makes sense. If you've ever decreased the volume in something, squished it together, you might have noticed that the pressure was greater in the midst. And so we can do a math problem with this. So a sample of oxygen gas has a volume of 0.425 liters when the pressure is equal to 387 kPa. The gas is allowed to expand, so it's able to expand into a 1.75 liter container. Calculate the new pressure of the gas. So right away we're thinking, okay, if it has expanded, the volume has increased, so thus the pressure will have decreased. It's expanded. So we plug in our numbers, write down this example, and then we just go through our algebra, get P2 by itself to find that the pressure, the final pressure, is 94 kilopascals. Next, we're going to talk about Charles's law. And this states that the volume of a given mass of gas varies directly with temperature of the gas when pressure is kept constant. So V1 over T1 equals V2 over T2. So if we increase the volume, the temperature is going to decrease. Or going to also increase, since these are division here. If you think back to like relationship or proportional problems in physics, this is very similar. So looking at this picture, we see if the temperature increases, the volume, something is going to expand. So we saw this with the balloon lab, was an example of Charles' law. So write down these notes, then write down this example. A balloon is filled to a volume of 2.2 liters at 22 degrees Celsius, but it's heated up to 71 degrees Celsius, so the temperature increases. So right away I'm thinking the volume is also going to increase. So I do my math, plug in my numbers, get the final volume by itself, and the final volume is 7.1 liters. So it has increased its volume. It went from 2.2 liters all the way to 7.1 liters, assuming that the pressure stayed the same. So I know that that is correct, that since the temperature increased, the volume also would increase. Next, we're looking at Gay-Lussac's law, and this has to do with pressure and temperature. So pressure and temperature are directly related when volume is kept constant. So if our temperature increases, our pressure will increase. If our pressure increases, our temperature will increase. So you may have also noticed this. If you heat something up really hot, the pressure inside increases. So if we increase the temperature, the pressure increases. Maybe you've noticed this if you have a water bottle that closes, like the water bottle I have right here. If this goes out into the sun sometimes, the pressure will build up in the water bottle, and I'll feel that when the temperature has increased. So looking at an example, bike tires are a great example. So you have your bike in the winter, the air pressure in the tire is 28 psi. The volume in your tire stays the same, but the temperature rises, so the pressure is also going to increase. So plug in my numbers to get the final pressure, and I notice that the pressure increases to 36 psi, which makes sense because of course our temperature rose, so our pressure should also increase. Those are the three laws, so make sure you have the definitions in your notes, as well as I like having these equations here. They'll be helpful for your math calculations. You could even draw this too with your arrows to know right away if something increases what will happen to the other variable, and so on and so forth. So notice in each of these, we're only changing one variable. You now will have 4 different practice questions. The first one is just summarize each of the 3 gas laws presented in this video, and then the next 3 are example of Boyles, Charles, and Gay-Lussac's. So use those to help you out. Pause the video, answer these questions. Make sure to show all of your work for questions 2, 3, and 4 in order to get full credit. Then upload a picture of your notes to Google Classroom. Feel free to email your teacher if you have any questions at all.